question in your homework is probably the number one asked question that I have in this lab book, so I'd like to go over it online, save me some time and help clarify for all of you. So first off, make sure you've turned there. This is problem number 37 and 38. In 37 it says calculate the density of each of the 9 samples to the appropriate number of significant figures. Alright, so the data that we're going to use for 37 is this table of data right here. It's mass and volume data, and it continues on over there. That confuses half the people on this problem. Alright, so it says calculate the density. If you remember, density is equal to mass over volume. Alright, so for each one of these, here's my mass and there's my volume. So in number 1, if we were to number them, you don't have to, but we have 0.50 over 0.71. When I divide that out, I have my calculator right here, I get 0.70. Now I wouldn't put the rest of those numbers because significant figures says if I have a division problem, I count the number with the least number of significant figures. Alright, that would be both of them have 2 because this 0 is important. So my answer is 0.70. Alright, so that's the density of our first sample. Here's our second sample. Let's do that math. Now I have 2 divided by 2.9. If I divide that out, I get 0.6. Hold on, let me type it in. 0.689. But since I can't put 3 values, I can only put 2. I have to round that, so 0.689 is rounded to 0.7. So that's the same number. Notice that. Alright, so this was for the first one, this is for the second one. Now let's look at this third one, which is 3.5 and 5.0. I take 3.5 divided by 5.0, I get 0.7 exactly. And I'm seeing a trend here. For all of these, the answer has been 0.7. That will continue on. And that is a good point. We learned just from this example that density is independent on the amount of the actual stuff you have. It's just dependent on the stuff. So for example, the density of 1 penny is the same as the density of 5. Alright, so 37. There you go. Each one of them is going to be 0.7. Now, 38 says plot the mass and volume data to create a graph of mass on the Y. So let's put mass here and volume on the X. Alright, now it says calculate the slope of the graph. Okay, so we're going to take these values that we just found and create a graph out of it. We have our mass and our volume. The first set we had was 0.5 and 0.71. So I'm just going to go, how far do we go? We go to 14. I don't remember. Let's just say it's, every other one is 1, 2, 3, 4, 5, 6, 7. Alright, and I'm not going to go into detail there. That's our volume. Our mass goes up to 10, so I'll just do every one. 2, 3, 4, 5. Alright, if I were to plot this data, I'd get half and 0.71. I would get 2 and 2.9. And I'd keep getting these dots in about this region. Now this is not really drawn to scale, but pretend I just drew a straight line. Now we have to find that slope, which is rise over run. But if you know what rise is, it's mass, and what run is, it's volume. The slope is equal to mass over volume, which is the same as the density, which you just figured out, 0.7. That's it.